some more vocab that we need to know about trapezoids, start diving into everything else. Is a trapezoid is a quadrilateral with exactly one pair of parallel sides. We've been talking about parallelograms, which have two pairs of parallel sides. Trapezoids only have one. Trapezoids are not parallelograms. They're still quadrilaterals. They're just not parallelograms.
Another question.
Yep.
Is there any of those like angles after the call just like congruent or?
Yeah. We have congruent angles and stuff. Just some of the rules are different because it's a trapezoid. Remember notes? We'll get those out.
Oh yeah.
An isosceles trapezoid is a trapezoid with how many sides do you think are congruent? Isosceles. Yeah, two. And those two sides are what we call the legs. Okay? Congruent legs. So we look at the diagram. I would draw this because you don't have one. So I would draw the diagram. So you have a good visual of what we're talking about. That's trapezoid. It has two parallel sides. So this guy and this guy. The nice flat sides, we call those the base. They're the top and the bottom. They're the base of your trapezoid. The nice straight flat ones. They're the parallel ones. The legs are the slanted ones. Those are not parallel. Those are slanted. In our isosceles trapezoid, the legs, again, the slanted parts, those are the ones that are congruent. So if it's an isosceles trapezoid, the two slanted sides are the ones that are going to be congruent.
How do you tell?
Because they're slanted. Flat ones are your base. It'll tell you, or have it marked. Yep, it will say this is an isosceles trapezoid in the directions, or it will have it marked in the diagram. So then you know it's isosceles. A median is a segment that connects the midpoint of the legs. So we look at the diagram, let's say this is right in the middle, and this is right in the middle. The median would be that segment. Okay. So if that segment's hitting those sides directly in the middle, it's cutting it in one. So it's directly in the middle, that means this piece and this piece are the same, and those two pieces are the same. So it's cutting that in half. Those legs. Okay. We also call this from Unit 3, a mid segment. It's also a mid segment. Median, mid segment, they go hand in hand. So if you see either one of these words, that's what we're talking about. This line that's going right in the middle. Okay. Questions about vocab? Okay. Some important theorems about trapezoids is both pairs of base angles out of an isosceles trapezoid are congruent. So the base angles are the two angles on the top and two angles on the bottom. That's what we're talking about, base angles. So these bottom base angles are congruent to each other. And these top base angles are congruent to each other. So the bottom two are the same, top two are the same. Okay. Also, what do we know about these angles still? They're like stacked on one another. What do these angles add to? 180. Because we have parallel lines. Here's your transversal. They're on the same side. So these guys are still adding to 180. Because these bottom ones are the same, and these top ones are the same. So that's still true about the 180. Top and bottom ones add to 180. Okay. Diagonals of an isosceles triangle are congruent. So if you have an isosceles triangle, the diagonals, the lines that go across, are the same. And another important one is the median of a trapezoid is parallel to the bases. So this middle line right here is parallel to the top and the bottom. So those three lines will never touch. And its measure in the sum of the bases. And we'll get to some examples, but literally all you have to do is add the top, add the bottom, divide by 2, and you have the distance of that middle one. And we'll get to some examples at the bottom. Okay? Questions over there? Okay. So, just like we've done with all the other sections, we have a proof. Woohoo! I know we all love proofs so much. They're our favorite thing to do. And they're not bad. They're just those triangle proofs. So it's like doing what you did in Unit 2. We all did well in that Unit 2 test, so. These aren't bad. Okay, so we have our statements. We have our reasons. What is our first reason every single time? Given. Every time. What's our first reason? Every single time. What are we going to write as our first statement? What are we going to write? Read? Yeah, what's given to us? So we were given that ABCD is an isosceles triangle. Okay, we're going to abbreviate. Okay? And then what's our last statement? Yeah, what we're trying to prove. We're trying to prove that AC is congruent to BD. Okay? So pretty much we're trying to prove that one theorem we just talked about, that the diagonals of an isosceles trapezoid are congruent. We're trying to prove that theorem. And essentially all we're doing with these proofs are those triangle proofs. So we're trying to find two triangles that are containing these two pieces and prove that they're congruent. Well, let's highlight those triangles. I'm going to highlight this triangle because it's containing that one diagonal. Right? And then I'm going to highlight this other diagonal. Okay? I didn't want to highlight this triangle right here because it is much smaller than this green triangle. So trying to make sure you have two triangles that look the same. One's really big and one's really small. You don't want to choose those two. They want to look the same. And that's going to be helpful for you.
So you want the biggest triangle you get?
No, I just picked these two. But you can pick a big triangle. The other triangle you pick also has to be a big one. Because then big triangle and small triangle are no way in shape going to be the same. So you want to redraw them. Same orientation. And keep those vertices the same. I'm going to re-highlight it in the diagram so we can see where they're at in the diagram. This guy was that way everything's not so smashed on top of one another and you get a better visual if you redraw them outside of the shape. We're essentially just trying to prove that these two triangles are congruent using what we know about isosceles trapezoids. Well, what's one thing we know about isosceles trapezoids? Back at that top, what's one thing we know? What do we know about the legs in our isosceles trapezoid? They're congruent. So if we look here, the legs are the slanted parts. Well, here are our two slanted sides. So I know those are congruent because it's an isosceles trapezoid. Mark those same sides in your diagram. We mark DA, so I'm going to mark DA. We mark DB, so CB, sorry. CB, so I'm going to mark CB. And then state that in your proof. We said DA was congruent to CB. What's our reason going to be? What's our reason? had a vocab word, what was our vocab word?
Definition of isosceles.
Yeah, very good. Give me definition of an isosceles. Okay. Because we had a vocab word, so you're using the definition of that vocab word. Okay. We know isosceles trapezoids. Legs are congruent. Okay, what else do we know about isosceles trapezoids? Okay, raise your hand. We know that their legs are congruent. What's another thing we said? Yeah, the base angles are congruent. So these bottom two angles, this angle and that angle, are the same. So D and C. Well, make those same markings in your diagram. We said angle D had one arc and angle C had one arc. Mark it in your diagram. And it's going to give you a good visual if you have those missing pieces. Okay. And we're going to state that in our proof. So we're going to say, looking at the green triangle, DCB. It's congruent to, if we went DCB in the green triangle, how do we have to name that other angle in the blue triangle? Yeah, CDA. We went from none to the green arc to the purple line, so none to the green arc to the purple line, so CDA. And again, what's our reason going to be? Sounds hard to say it. Did it change at all? We knew those angles are the same because we knew it was an isosceles trapezoid. So our reason's still going to be definition of an isosceles trapezoid. That vocab word didn't change. Now, some of you have been saying this. What do you notice about these two triangles? Look back in that diagram. What do you notice that they are sharing? Sharing what? That's not a mid-segment. They're sharing a diagonal.
See, what is number 3? Reason set?
Definition of isosceles trapezoid. Start to say it. Yeah, they're sharing side DC. Well, what did we always say our reason is when they're sharing a side? It's a reflexive property. Whenever they're sharing a side, it's a reflexive property. And you just say that side's congruent to itself. So DA is congruent to, DC. Not it. DC is congruent to, they're flipped, so DC. Oh, mark it. This is the shared side that's congruent to itself, so I'm going to mark it in my diagram. Can we now say that these two triangles are congruent? Yeah. By what? What 3 pieces do we have? Side, angle, side. We have a side, we have an angle, we have a side. So again, it's nice. We already said that 2 angles were congruent. You just change that to a triangle symbol. So that triangle is congruent to that triangle by side, angle, side. You're done. What's our reason going to be once we prove the triangles are congruent? What's our reason every single time? Okay. You're not going to have that tricky one on your test. But again, it's good to see the review get more. Okay. And it's really helpful if you redraw those diagrams. And that's all these proofs are. It's parallelogram, rectangle, whatever, Ramas proofs. It's just you're proving 2 triangles congruent using what you know about the type of parallelogram or type of quadrilateral you're given. essentially you're just using those things that you know about those shapes to prove the parts congruent. So you can say that the triangles are congruent. So it's literally unit 2. You just have more information you can use. Perfect timing.
Great timing. Sorry about that. Let me know, Coach, you was not helping. So some other things. All right, so let's go here. DEFG is isosceles trapezoid with median MN. Great. Let's find MN. Where's that? Right there in the middle. If EF is 12, EF's up here, it is 12. The other one, DG, is 14. How are we going to figure out what MN is? Jason, idea.
Well, I was gonna say a different thing, but if we're trying to figure out MN, we could treat them as two different trapezoids.
You can look at it that way. Now, that might not necessarily help us out here to figure out that. You're saying look at the top one or the bottom one. But I do know a property, because what kind of segment is that MN segment? Think about where it's at. It's a mid-segment. There's a rule we know about mid-segments based on the top base and the bottom base. Remember that rule?
The book equal book. I was gonna ask, so use that.
Oh, okay. Hold on a second. There's upside down. But in this, who can tell me that rule? It's one of the last rules you had on your little rule sheet. What is it about? It's half of the sum, right? So all I have to do is add these together and divide by 2. So I'm going to do 12 plus 14. What's 12 plus 14? 26. And then I'm going to take that number and I'm going to divide by 2.
I forgot to turn something off.
26 divided by 2 is 13. Again, this one, you guys probably could have figured that out, right? You guys could have figured that out and said that's 13 as well. Great. Because it's going to be between 12 and 14. What number is between 12 and 14? 13. All right, so if I DG, if E is 20, and I get able to erase this so we go again here, MN is 30. So let's see here. All right. So I know I'll go a different color here. EF is, oh no, I lied here. EF is 20, and then MN is 30. Uh-oh. We want to figure out what DG is. Figure out X. Again, some of you with your big brains can look at this and say, I know what it's going to be. But let's set up an equation in case you don't know what it is. All right? Well, I'm doing the same thing. I'm going to add the bases and set them equal to that middle segment. All right? Well, what are my two bases here? I have two. What are the two base values? 20 and 30 is not my base, though. 30 is my mid-segment. X. So I'm going to say 20 plus X is equal to my mid-segment of 30. All right. Oh, I didn't do the 2, did I? That's why I messed up here.
That's me.
Okay.
20 that's 2.
Divided by 2. There we go. Messed that up here. I'm thinking it's like, that's not going to be right. That's going to be the increase. But 20 plus X divided by 2, right? Because I have to, whatever the answer is, divide by 2. Just like I did up here. All right. Well, if I'm solving this problem, how do I get rid of that 2 in the denominator? How do I undo a fraction? Multiply. So I'm going to multiply both sides by 2. Again, I don't have much room here to do it, but we can do it real quick. Multiply by 2, multiply by 2. So when I do so, those cancel out. I'm now left with 20 plus X is equal to 60. And I have one last step. What do I subtract 20? Minus 20, minus 20. So X equals 40. And again, another one to do this too, another way to look at this is sometimes helpful is, I know it's exactly in the middle. So I'm saying, how much changes from 20 to 30? What's the difference between 20 and 30? 10. So I know the difference between this and this number also has to be 10. So if I do, what's 10 plus 30? 40. Another way of thinking of it. Might not work out well with this way, but let's try it out here. So now we have other pieces. Find the measure of the interior angles if that's what they are. I'm going to erase it so we have room to work there, but let's see what we're talking about. The measure of angle 1 is 3x plus 5. Here's angle 1 is 3x plus 5. The measure of angle 3 is 6x minus 5. 6x minus 5. I need to figure out what the measures are. So how would I set up an equation with this? Aaron.
3x plus 5 plus 6x minus 5 equals 100.
It does equal 180. Again, it doesn't work for both of these, but these angles that are the opposite of the legs, those angles are going to be supplementary. So it's not always in trapezoids angle side by side, because there's something special with 1 and 2, especially with the being isosceles. But I know these angles on the bases will be supplementary. So 6x minus 5 plus 3x plus 5 is equal to 180. And you guys are getting pros at this. You know that once I write the equation, that next step is going to be combining those like terms. Some of you guys are already going for it. Go right ahead. 3x, these 5's go together. Let's see what's going on. 6x and 3x is a 9x. Calculator's up. Negative 5, minus 5 plus 5. 0, I tricked you. You didn't need a calculator for that one. They go. Equals 180. Last step. Thanks for shouting out, everybody. Divide. So what is 180 divided by 9? 20. Good, we're done, right? Done. Move on to example D. Why did Derek say no? Derek, I found X, I'm done. It's right there. Oh. Because does it say anything about finding X? No, it says find the angles. So again, I do have to plug that in. So I'm going to have two angles. I'm going to go right here, plug it in. So it's going to be 3 times no longer X. It will now be 20 plus 5. 3 times 20 gives me a 60 plus 5. 65. Great job there. This guy's 65 degrees. Two different ways to look at it. You could go ahead and plug 20 in the other one, subtract 5, or you can do 180 minus that 65. Doesn't matter. I'd say it's probably a little easier to just go up here and plug it in. So I'm going to say this other one now is going to be 6 times 20 minus 5. 6 times 20. 6 times 2 at a 0. All right. Minus 5. 115. So I know that this is going to be 115 degrees. What's all this? Again, you're just substituting values in.
What would angle 2 be then?
Ooh, good question. I hear 115, I hear 65. Good news is one of you guys is correct. It is 65. Why do you know it's 65? Because what type of triangle is? You guys are right. What type of triangle is this? Isosceles. So we know in isosceles, triangles, and trapezoids, those base angles are congruent. Okay? So this is the one where the opposite sides are not congruent. They're actually going to be supplementary. So this is also 115 up there as well. These are both base angles congruent. Questions on that one? It's a good one. Do this one too? Okay. So, let's go ahead. This is a good one. Before, when we did a problem like this one, no, I lied. Where's it at? When I label these ones here, it's easy. You can see the difference. You can count. Well, if I know the number is between 12 and 14, it's got to be 13. If I know this one, if one's 20, then the next one's 30. Well, the next one I add 10 more to find it to be 40. That's easy to do. But you're definitely going to have to use this formula for this type of problem. Because I don't have numbers. I can't see what it's increasing or decreasing by, whatever it is. But I want to find the lengths of these segments. So we got the bases and that mid segment in there. All right. Let's go ahead and do so. Well, it's just like we did before. Add the two bases. Give me one of the base values. I don't care which one. Give me one of the base values. 2x minus 12. Good call. 2x minus 12. Let me throw some down. I'm going to add that to the other base. What is the other base that we did not label? X minus 8. So x minus 8. All of this is going to be equal by what? Or over what number? 2. And they always equal the mid-segment. And the mid-segment is x. Good. That's our equation. Looks crazy, but it's not crazy. All right? So let's go ahead. Again, we're going to combine some stuff as we can here. Or you could have multiplied, however you want to do it. I'm going to combine stuff, just keep it simplified here. Stay consistent. So 2x plus x gives me a 3x. Negative 12 minus 8, negative 20. Still over 2 equals x. And somebody's going to ask this or say, well, can't I just divide 20 by 2 and 3? You could. I would recommend still getting rid of that fraction. Sometimes it works out. If 3 was a number, an even number, you can reduce that right away. It wouldn't be an issue. But can I divide 3 by 2? Does 2 go into 3 evenly? No, it's going to be not so nice of a number, or if anything, a fraction. I don't like that, so what I'm going to do is get rid of this 2 like I did before. How do I undo something that's dividing? I'm going to set it. Multiply. So multiply both sides. He gone. So now, where's my scrolly thing? So now I'm left with 3x minus 20 equals, what's 2 times x? 2x. Don't say x squared, because it's not x times x, it's 2 times x. It's 2x. And now we have a better problem. Someone's going to say this, and it's going to be weird, but it's acceptable if you want to do that. Normally we move which x first? We use the smaller one, right? We normally do. If I move the smaller one here, there's nothing on that same side. It doesn't matter. It would just be a 0, then you have your next step. If you want to stay positive, let's go ahead and do that. I'll just do it, just so we stay the same, and we always move the smaller x first. So minus 2x. So when I do so, what's 3x minus 2x? X minus 20 equals, well, 0. There's nothing there. You have one more step. If you were to subtract it, you'd have to divide, but whatever it is, add 20, add 20. So x is equal to 20. Found it. We good? No. Correct answer is no. So I know x is 20. Well, let's go fill in our values. Well, the nice thing is, that's 20. This is x by itself. When I plug it in up here, it's going to be 20 minus 8. What is 20 minus 8? 12. So this segment is 12. You can now see the difference between these two and figure out what's going to be the next one, or just real easy, plug it in. So I'm going to do 2 times 20. I had to think about that for a second. Minus 12. 2 times 20 is 40 minus 12. 40 minus 12 gives me a 28. And you know it would have been that because this is increasing by 8, so that will increase by 8. So good. Questions? If you know how to do it this way instead of kind of that guess and check thing, you'll be fine. Ask questions.